Today we're going to be moving into chapter 11 where we're going to be studying different series and sequences. And these are just number patterns and they're really neat. Some of them you might be able to do in your head. So let's look at section 11.1. And the first thing I'm going to show you is this pattern of triangles and squares. And if we look at this pattern, we can see that it goes triangle, square, square, triangle, square, square, square. And so in your brain, you can say, well, I think the next pattern is going to be in triangle. That's our next shape. Let's look at the next pattern. We have a circle, triangle, square. Circle, circle, triangle. Square, circle, circle, circle. Triangle, square, circle. And if you think about it, the next one, it must be a circle. And that's just a pattern that we can kind of deduce and figure out on our own. But let's look at some different numbers. If we're looking at this number pattern of 0, 3, 6, 9, 12, and 15, what do you think the next number will be? Well, looking at this pattern, it seems pretty obvious that each number goes up by 3, and so our next number is going to be an 18. And so we can deduce some of these number patterns in our head, and sometimes they're not as simple as that. Let's look at our last warm-up. 1, 4, 9, 16, 25, 36, 49, and then what? Well, if we think about this, we go 1 to 4, 4 to 9, 9 to 16. They're all squares. So the next number that would be a square after 49 will be 64. So a sequence is a group of numbers that changes according to some pattern. It is a function whose domain is the set of natural numbers and whose range is the set of term values. Each number is assigned with a spot in a particular symbol. So if you look at this, we have a sub 1, a sub 2, and so on and so forth, until we reach something called the nth term. And the nth term is whatever term you're looking for in that sequence. And so if we look at this following sequence, 1, 4, 9, 16, 25, 36. And we assign a position for each of those numbers. So a sub 1 is number 1, a sub 2 is number 4, a sub 3 is number 9, a sub 4 is 16, so on and so forth. And we're asked the question, what would the 10th term in that sequence be? So we would go a sub 10. And we would need to think about this. If we look at this pattern, a sub 1 is 1. That's the same thing as 1 squared. 2 squared is 4. 3 squared is 9. 4 squared is 16. So then a sub 10 would be 10 squared, which is 100. We can do this for any nth term in that sequence. And so sometimes it's really, really easy for us to find a number pattern, but often it can be a challenge and we need to use a formula. And so when we're doing a sequence, we have to follow a certain amount of steps. You want to discover a pattern. Look at it, think about it. Write a few more terms of the sequence. Get a formula for T sub n, which is actually written like this. Use a formula to calculate the other term values, and then draw it to look at the sequence. So let's look at an easy example. And in this example, we are given 3, 5, 7, 9, 11, 13, and 15. In this number pattern, it's easy to see that our numbers increase by 2 every time. That's our pattern we've discovered. If we write a few more terms, it would be 17, 19, 21, and 23. And now we need to get a formula for T sub n. So this is writing it out long ways. You may not need to do this. Many times this comes very easy and you won't need to write out all of this step. But for our first one, I will show you. So you write out the term values, and that's your T sub n. And then I assign a number to each of those values. So 3, 5, 7, 9, those are 1, 2, 3, and 4, and that's our n. And if we're looking at it, 2 times that value, I've written that there. So in this example I'm giving you, the value of t sub n is always 1 more than the value of 2n, looking here at this example problem. And so to find the next value, it would be t sub n equals 2n plus 1. And so you can check your work, because if we take, well, let's look at number 3. So if I have 3, which is 2 times 3 plus 1, I'm going to get to the next number in the sequence. But let's find a large value. So if we're looking at t sub 256, how would I calculate that? And what I would want to do then is to take t sub 256 and set it equal to 2 times n, which is 256, plus 1. And that value comes out to be 513, which means if we're looking for the term, the 256th term, that would be 513. And so then the next step in these is to graph it. And so we want to make sure that we're only graphing integers. So it's only a dotted line, and right now we're in the positive quadrant 1. So if I would go ahead and graph this, I would have a value at 3 and 1 and 3, sorry. I'd have a value up here at in between 5 and here. And so then this dotted line connects. And so we can see that it is growing upwards with these integers in this number pattern. So let's look at one more. So if we look at the next one, example number 2, we have 2, 6, 12, 20, 30, 42, and 56. I can look at this and say, okay, so we go 2 to 6, that's 4, 6 to 12, that's 6, 12 to 20, that's 8, 20 to 30, that's 10, 30 to 42, that's 12, and so on and so forth. But we're being asked to find a formula. And so naturally, in my brain, the next number I believe that would be here would be a 72. But how do I find that formula? And so that formula is found by taking t sub n equals n times n plus 1. And so you can use this formula on this example to find any n. So let's find t of 1,000. So then I would write 1,000 times 1,000 times 1,000 plus 1, which is 1,001. And if I plug that into a calculator, I come out with 1,001,000. And that would be the 1,000th term in that sequence. These are pretty simple. So what you're going to do are a couple of problems, just 7 in chapter 11. And then when we meet tomorrow, we're going to be talking about some other types of patterns that are a little bit more challenging. Please reach out if you have any questions.